So we've got here, we need to find a stationary point between 0, x and pi. In case you don't know what sine looks like, sine goes like this. So if I'm squaring all the values, and I'm going to do it in a red, then it's roughly going to look something like this. It's going to go up, it's going to peak at the same value, it's then going to come back down. But where we have these negatives, it's going to just sort of flick back up, like so. We're not going to get a negative, because a negative squared becomes positive. Now say I want to find these stationary points, it's where dy dx is equal to 0. We're not increasing, we're not going upwards, we're not going downwards, we're just gradient of 0 with flat line. So say we want to find dy dx. Dy dx is going to be, we bring the 2 down, we differentiate the inside, so that becomes cos x, and we put the old back in, and we minus the power. This is going to be the same as 2 cos x sine x. Dy dx equals 0 at the stationary point, so 2 cos x sine x equals 0. If you're not sure what this is, it's the same as sine 2x. We proved the compound angle formulae. We didn't prove the double angle formulae, but you can use them compound angle formulae that we found to show this result. So we get sine 2x equals 0. We can then solve for sine. So when does sine 2x equal 0? Well, when 2x equals 0 or 180. Well, not 180, we're talking about radians. And that's a real key thing. A lot of people forget that when we're drawing a graph, we're talking about radians. We can then divide by 2, so x equals 0 or pi over 2. This 0 here is not inside our bound, it's greater than but not equal to pi. Whereas pi over 2 is, so x equals pi over 2. We could now put that back in. I believe our y coordinate would just be 1. I hope that was useful. In the next video we're going to determine the nature. Thanks for watching.